Now we're supposed to formulate this scheduling problem, all right? Be careful, I'll try to explain you many tricks while we're doing this, all right? First of all, what do you think our variables are? What is the main variable? Decision variables are. Yeah. Decision variables. Some of them you can say, yeah? Number of shoes I produce in each period. So let's say PT, number of shoes produced. Produced at month T. So I have to tell that T takes values from 1 to 4. Okay, I definitely need PT. Now, for the sake, for the sake of formulation, I need additional variables too. For example, I'm going to define IT, number of shoes in inventory. Çok yaşa. Number of shoes in inventory at the end of month T. I define a variable for my inventory because it has a cost, $30, and I have to make sure my inventory is actually keeping up with me to satisfy the demand. So I need to define it as a new variable. What else do I have? I need to know my number of workers. Currently, there are 3, but I can hire and fire them, so I need to know how many workers I have in each month. Number of workers working on month T, at month T, all right? What else? Well, just a quick hint. It's nice to check the costs. Apparently there's a cost for hiring and a cost for firing. So let's define HT. Number of workers hired. And FT, number of workers fired for month T. Okay? Well, the production amount is definitely, that's the trivial variable. You need to know how many you're producing that month. The rest, we need them to come up with the correct formulation. Okay? So PT represents my number of shoes. IT represents my inventory. W2 represents my workers. H and F of T represents the guys I fired and hired. All right? Now we're going to formulate this step by step. Yes?
Do we need to do W because it's going to change based on H and FT?
Yes, it will change based on HT and FT, but it's easier to start like this. Some of them, they're called induced variables. With the rest of the group, you can write it as a function of the rest of the group. But for the learning purposes, let's start with that. We will have an equality, yeah. Okay? All right, my decision variables are my last page. Now, let's look at the demand of period 1. I have to have 300 shoes in my so that I satisfy the demand, yeah? Now, What can I use to satisfy the demand of the first month? Yeah? Yes. So I'm producing for month 1. I'm producing P1. And I have inventory coming from last month, I0, which is 50, yeah? I already know this. The amount I produced this month plus the thing I carried from last month should be equal to my demand of this month, which is 300. But I could also leave some for the next period. I have utilized previous period's inventory. So that is called inventory of 1. This is called flow balance. So the general version is production at month T plus what's coming from the previous month should be equal to demand of this month plus the inventory of this month left over. Be careful, this dt is the demand. It's a parameter, not a variable. The rest are the variables we just defined. This is very important. This type of equation is really important. We do it a lot whenever we need to do balance. This is very similar to the balance we did for the investment. Right? Money cash in was equal to cash out. This time, the things that's coming to me this month from the previous month and the things I'm producing should be my demand and anything that I'm carrying out for next month, whatever is needed. All right? Is this clear? This is really important. So if we write it in an open form, the P1 is already here. For example, P2 plus inventory 1 should be equal to 500 plus inventory that's going for the next semester, next month. Then production in 3 plus the inventory coming from previous month should be equal to 100 times inventory I'm carrying out for the next term. And finally, production in demand in period 4 plus inventory coming in should be equal to, it's 100 again, times anything I'm lefting for, which is meaningless. This should be equal to 0 if I'm only planning for this 4 months. Okay? This is called inventory balance equation. And if you're producing anything, you will definitely need something like this. Is it clear? Is it clear? Yes. Okay. Now, how about the workers? Currently, W0 is 3, right? On month 1, when T equals to 1, what are the workers that are working right now? The ones that are coming, plus, this is W0, plus the ones I hired this month should be equal to the ones I'm firing plus the guys working next semester. Let me do this like this first. Hold on. Let me write it in the open form first. WT, the workers that are working this month, plus the ones I fired, actually are coming from T minus 1 plus, hold on, I hired. or you can, this is easier to see, so the workers working this month are the workers working last month, plus the ones I hired, minus the one I fired. Yeah? This is the same equation with respect to the number of workers. Right? The workers I have this month is actually the workers coming from the previous month, plus the ones I'm hiring this month, minus the ones I'm firing this month, will give me the workers I have for this month. Clear? Any questions? All right. Now, we have the inventory balance. Yes. We have the workers balance. Yes. So let's see. The 50 pairs of stock handled. We put this. The cost will come. 3 workers done. Salary will come. These will come. But how about this thingy? A pair of shoes require 4 hours of labor. How do we write that? Now we have to, now this is an optimization model, right? Once you start solving these things, the solver has no idea what W represents, what P represents. They will just be numbers at the very end. But then, okay, I have some numbers related with my W's, and I have some equations related with P's and E's and demand. But there is no relation in between them. Normally, my production is determined by number of workers. So I have to teach the model, the realistic, everything that's happening in real life should be applied, should be written in here. So I have to teach the model that each worker each shoes of labor, each pair of shoes require 4 hours of labor. There is nothing related to that right now. I do satisfy my demand with this inventory balance. I'm taking care of how many workers I have, yeah, but then how do I link this number of workers to my production? Yes?
We can say that PT is equal to 160 over 4 multiplied by the number of workers.
The production amount and the number of workers should be linked together. There's an easier way to do that. What I do is, now for each production, I need 4 hours of labor. Yeah? Okay? Every worker works 160 hours for a month. If I write this constraint, 4 PT is at most 160 WT, everybody will come with a cost anyway. So that at the end, the optimization will make sure that for production, I have enough number of workers. Got it? This actually brings us to the formulation that I have written in the break on the left. So my decision variables, PT, production amount, IT, inventory, WT, my number of workers, HT and FT, hired workers, fired workers. Those are my variables. Objective function, okay. For each firing, it was 2,000 and hiring was 1,600. So for fired workers, I'm paying this much. For hired workers, I'm paying 1,600. What else? Each worker was 1,500 per month. So for every worker for WT, I'm paying 1,500. For inventory, I was paying $30. And for each production amount, I was using $5 of raw material. So that comes with 5 times PT. That's my objective function. Every cost that's written in here is actually represented in my objective function. My constraints, I have inventory balance, and I have workflow balance, workman balance, labor balance. Yeah? You have to tell what I0 and P0 is to the optimization model. Those are current settings. And I have to link my production amount with my workers. Everything has to be positive and integer valued. You cannot have fractional pairs of shoes or fractional people working. So everything is integer. And the one on the left is actually the formulation for the workforce scheduling problem. Is it clear? Do you have any questions? I'll wait for you to finish writing. Any questions? Okay. Now, as I told, you have to link these things with each other. You have to tell that there's a relation between production amount and workers. Otherwise, I would continue, well, depending on the cost, I will kick my workers by paying their $1,600 for month one, and then I will not have any workers. Every other WT will be zero. But then in the meantime, my production can be some values. However, if you don't have any workers, you cannot produce. The problem says each worker works 16 hours, 1,600 hours, and you require 4 hours of labor for one pair of shoes. So your pair of shoes is PT for month T. 4 times PT is the labor hour you require for month T. And 160 times WT is actually what you have for month T. Got it? Any other question? Clear? Okay. Well, this set of slides does a similar thing, but the formulation is on the slides already. So if you have downloaded it, you would have seen it. Again, production planning, all right? Now we have 3 different types of products, and we have weekly demand, 4 weeks demand for each product. So we have like 12 demands in here, right? Okay. Again, each product requires different labor hours. For product A, I require 3 hours of labor. Product B, 2 hours. Product C requires 4 hours of labor. All right? What else do I know? Okay, here's my environmental settings. During each week, I have 120 hours of regular time of workers. And this regular time costs $10 an hour. But I can also use 25 hours of overtime if it is required. It costs $15 an hour. All right? Regular hours, $10, and in a week I have 120 hours of such. Overtime, I can go at as much as 125 each week, but they're costly, $15 per hour. Okay? No shortages, so any amount that's required in here should be satisfied. So at week 1, I have to have at least 25 product A, at least 15 product B, and at least 10 product C. I can have more to use in the next week, but I have to have at least that much. That is called shortage, if you don't have enough. Of course, I start with some inventory, again, 18 for A, 13 for B, and 15 for C. All right? We're going to assume that anything I produce in this week will be used in this week. We did that in the previous thingy too. Anything I'm producing, I'm using it to satisfy the demand of this week. All right. Now we're going to determine an integer program. We're going to write an integer program which will determine the schedule, production schedule, that minimizes the total cost. Okay? Here are the variables then. The demand, I have also defined it, dt in the previous problem too, those numbers, so that you can write the compact formulation. That's what we're going to do again. For product A in dt, so dit may be product AT, product BT, demand BT, and demand CT. Yeah? But these are parameters. They're given to me with certainty. My variables are the amount of product I produced during week J. Okay? So I have X, A1, A2, A3, B1, B2, B3, right? Xij, amount I produced from product I in period J. That is my variable. Of course, there's this production balance thing. Yeah, I would need my inventory. Inventory Ij, amount of product I left in the inventory at the beginning of month J. And there is also a decision of using overtime or not. So let's define a variable for each week. Shall I do overtime this week or not? Be careful with the indices, right? Overtime, it doesn't go to A, B, or C. It is the overtime of the week. So overtime variable only have the indices from 1 to 4. Do I have overtime this week or not? Other than that, the rest is there. So I'm ready to formulate, yeah? Let's recap. 3 different types of products for 4 weeks. So my Xij represents the amount I'm producing in week J from product type I, all right? Inventory variable also goes with I and J because how much of which type of product I'm having in my inventory is important. So X and inventory variables with paired indices, and I have an overtime variable. Production constraint. This is the inventory balance we did in the previous thingy, but this time there are different types of products. So inventory of product I in J-1 period, coming from the previous period, plus what I have produced this month, minus the demand of this month, is actually what's going on to my inventory to be used next month or the month after. That is the inventory balance equation. For example, this is the open form for product A. Currently, I have 18 in my inventory, plus the production I did in period 1, minus the demand is actually the inventory of product A going to period 1. Period 1's inventory plus the production amount of day 2 minus the demand will be equal to inventory of product A of period 2. That inventory plus the production minus the demand will give me the inventory to be used in period 3. And there, the inventory coming from the previous period plus what I have produced minus the demand is what's left for my inventory at the end. This is just for product A. You do the same for B and C. Okay? This is just the open form of what I have written in terms of T's only. These are inventory balance constraints, production constraints. Clear? Was it too fast? Do you want me to go over or clear? You have to say something. I'm assuming it's clear, so I go on. Now, it says no shortages. How can we do this? I have written the production balance constraint anyway. What makes sure that I don't have any shortages? I satisfy the demand every time. Yes? Yeah. If I write this, inventory can never be negative, then in these constraints, I'm actually making sure that the demand is satisfied. Very good, thank you. What else? Labor. Remember? There is this regular hour and overtime. And also I have these requirements in here. Where are they? 3 hours for product A, and that is, product A requires 2, product A requires 3 hours of labor, B requires 2, C requires 4. Okay, let me go back to the correct slide. Labor constraints. In the previous hour, it was 4 hours for each produced product, and I was balancing it with the amount of workers I have, right? 4 times PT was less than or equal to 160 times WT. This time, I don't have number of workers. I do have the hours available, yeah? Regular hours and overtime hours. Here is the constraint then. Let's look at it individually. XA1 represents the amount produced in period 1 from product type A. Each product A requires 3 hours of labor, so this is actually the labor I require for product A to produce in week 1. Each product B requires 2 hours. This brings me this. And this is 4 hours for product C. Now, what do I have on the right-hand side? My regular hours are 120. That's what it says in the environment. Plus, I may have overtime if I require it. So whatever overtime is required in period 1 will be determined by this. If the summation of these x's is needed to be more, let's say 120, that means I'm having, 130, that would mean that I'm having 10 hours of overtime in week 1. Is this clear? Because this is a pretty nice trick that we're doing in here. The production amount with the required labor should determine me, should be bounded about by the amount of labor I have. In terms of regular hours, I have 120, but each month, each week, I may have overtimes, which are written on the right hand as an additional capacity for me. Clear? These are my labor constraints. Now I managed to link my axis with the 120 hours plus overtime. Is this clear? Yes or no? Yes. I need to tell the model that the overtime cannot be more than 5 hours. That was given to me again as an environmental requirement in the problem setting. It says every week I have 120 hours of regular hour, and I may go up until 25 hours of overtime if required, right? So each IT should be less than or equal to 25. I can't have more than that, all right? Is this clear too? All right. Now, the objective function is pretty crucial in here. We usually add up all the costs that we have, right? Let's go back and remember what the costs were. Here they are. Here they are. I have 10 hours for each hour, regular hour that I'm using. Then I have $15 for overtimes. Do I have a cost for inventory? Apparently no. Yeah, that's it. Everything is going on with the labor wages then. Now let's look at the objective function. There it is. It's an interesting objective function, be careful. Now I'm paying for this time it doesn't say every worker gets this much per week. The workers are paid on the hours that they work. Remember? Let's go back. It says $10 per hour of working. Now, how many hours are they working? That is determined by this labor constraint in here. How many hours are they working? This much. They're working this much, right? So actually, now for every product A they're producing, I'm putting 3 hours. And I do this every week. For every product B, I'm putting 2 hours. And for every product C, I'm working 4 hours. This is the total, regular or not, total hours, be careful. Total hours of work. That goes with 10, and overtime comes with a 5. Normally, overtime was added by 15, but that overtime is in here also. Some of it is in here. That's why this is the trick we're doing here. So I'm assuming that I'm paying 10 for every hour they're working, because this whole thing is the total worked hours of all those 4 periods for my A, B, C. This does not distinguish. When I'm producing the product, I don't know if it is produced in regular hour or in overtime hour. I don't know, right? So this is my total labor hours. That I know. Now I'm gonna pay 10 for it, for sure. And actually the ones that are overtime, they're coming with an additional 5. Because 10 was regular and 15 was overtime. I don't know how many of this is produced in overtime. And I don't care, as long as I put the correct terminology in here. This is a trick. And this trick actually helped in formulating it. Otherwise, you would need to distinguish your axes, the production being in regular time or overtime. But I didn't need to do that by writing the objective function like this. This is pretty challenging, but once you see it, it's correct, right? The beauty is trying to do it on your own, which will come in time. Do you have any questions with the way I have written the objective function? This is the challenge in this formulation. Again, I repeat, I don't know which product is produced in regular time or overtime. I don't care, right? All I need to know is I have enough hours available. Now, this constraint here makes sure that I don't pass the capacity, whatever I have in my hand. Again, these constraints make sure how many OTs I required, overtimes I require. They all come with an additional cost, right? If I don't have to use it, I don't use it. The optimization will take care of it. But the important part is, can I represent everything linearly? And yes, we did. Any questions? This is the overall formulation. Altogether, as you see, I'm minimizing my total cost. I have my inventory balance equation. Then I have my labor hour requirements, and I have my non-negativity. Clear? Thank you. Well, I mean, for OT, it depends. Like, if the guy worked like 10 minutes, do I pay for an hour? I'm assuming yes. So, yes. But if it is not, you could say only the production amounts are integer and overtimes are non-negative only. But as long as you have at least one integer variable thingy there, it's going to be integer program. Any other questions? Cutting stock problem now. Be careful, I'm jumping over many different versions of integer programs. Please go over them on your own and really make them sink, because when I'm explaining it here, it might seem okay, but it's good for you to read them on your own too, because we're gonna be, like on Thursday, we will have a lot more challenging things going on in here, so you should be done with these preliminaries. Cutting stock is, again, a very cliche problem, let's say. Okay? It appears a lot. It can be, it has many applications. The application I'm showing here is coming from a paper company, okay? The paper company produces and sells rolls of paper with fixed width, but in 5 different lengths. So whatever the width is, but the lengths can be 5, 8, 12, 15, and 17 meters. Meters and paper, okay. I guess this was coming from a different example. And here is the demand underneath that, okay? So this is the demand, like 40, 35, 30. I need to have that much of 5 meters, like 40 sheets of 5 meters, 35 sheets of 8 meters, and it goes like that, right? Okay. My overall thing is being cut from something which has a 25 meter, okay? So how many rolls do I need to make this possible? Now, it's normal in 2 dimensions, but one of the dimension is left out. Whatever it is, it's okay. So we're only focusing on 1 dimension. My raw material is coming with 25, okay? And I need to cut it to 5, 8, 12, 15, and 17. How do I cut it? So that the scrap is minimized. And I satisfy this demand with minimum number of rolls. Any ideas for the decision variable? How do you think we're going to do this? Challenging problem, huh? This is what we need. Cutting patterns. Let's first figure out what can we do with this 25. I need 5, 8, 12, 15, and 17. 25 has no meaning for me other than that's my limit, right? So what can I do? I'll have the 25. I can get 1 17 and 1 8, right? That's a pattern. If I want to have 17, I could put a 5 also. I'll have 3 scrap, not used. Nothing else. With 17, nothing else can happen. Yeah? With 15, if I cut 1 15, the remaining can go to an 8 with some scrap, 2 5s, no scrap, and that's it. Nothing else can happen with 1. If I cut 1 15, nothing else can happen. If I cut 1 12, what can I do? I can cut another 12, and 1 meter goes for scrap. I can cut an 8 and 5, no scrap. I can cut 2 5s and some scrap. What else? I'll do 3 8s, or 8 8 5, or 1 8 3 5s, or I'll cut 5 5s. Nothing else. No other pattern is possible. Think about it. Those are all options. Those are all the things that I can cut this 25 meter with in order to come up with this 5, 8, 12, 15, and 17, right? Because I want to go there. Well, like I might have 3s, but I'm not selling 3s, so it doesn't make sense. So this 25 can only be cut in 11 patterns only, so that I sell the output. Now tell me your decision variable. Now we are ready. Yes?
Number of rolls which is cut according to this cutting pattern.
Yep. So xj represents number of rolls I used for pattern J. J goes from 1 to 11. I have 11 patterns. Remember? I have 11 patterns. Now, okay. How do we write the constraints then? I have defined my variables with respect to my patterns. Now each pattern also tells me what it is cutting, right? For example, let's look at the 12. I need to have 30 12, right? Now let's look at my patterns and see which ones actually give me 12. I can get one from 5, pattern 5, one from pattern 6, and one from pattern 7. So there's some. No, I got 2 from pattern 5, sorry. I'm looking at the paper I got with 12. You look at your patterns. For each pattern 5 you're cutting, you're getting 2 outputs of 12. So 2 times x5 plus x6 plus x7. For each pattern of 6, you're getting 1. Each pattern of 7, you're getting another 1. Their sum should be at least 30 because I require 30 from 12 meters of paper. Is this clear? Let's do the 5. Let's do the 5. Tell me the constraint for 5. I already marked the correct patterns. Tell me the constraint for 5 meter inches, 5 meter length ones. Yes?
x2 plus 2x4 plus x6 plus 2x7 plus x9 plus 3x10 plus 5x11.
Exactly. It has to be at least 40. Everything I see, x2, each pattern 2 gives me 1. Each pattern 2 gives me 2 5s. Each pattern 6 gives me 1. Pattern 7 gives me 2. 1 in here, 1 in there. Pattern 9 gives me 1. Pattern 10 gives me 1, 2, 3. And pattern 11 gives me 5. X1 represents, X11 says how many of pattern 5s I'm cutting. So this sum should be at least 40. So that I satisfy my demand for 5. This is what it is then. Minimize the total number of rolls for each pattern, X1 up to X11, because X1 says the number of things you cut in pattern 1, pattern 2, and you have to satisfy your constraint. You have to make sure that the demand is satisfied. Again, it's integer because you cannot cut half of a pattern. It doesn't make sense. Clear? Any question? Okay, I repeat, go over the material we did today. The practice sessions, we will be focusing on linear programs, but Thursday's project selection is really crucial. Everything that you need in all the challenges that you can face in terms of integer modeling is in project selection. So also be here on time on Thursday morning. All right, see you in practices.